Science Journal for Kids and Teens presents How Many Legs Does It Take to Escape a Predator? Read by Miranda Wilson. Abstract. Why do animals have such different shapes and sizes? Many animals are hunted by predators. Prey animals have features that help them escape these predators. For example, some animals like frogs have two powerful back legs to jump away from predators. Other animals, like deer, have 4 legs that help them run away to safety. Some rodents use 2 legs, while many other rodents use 4 legs. But which ones are better at avoiding predators? We compared the bipedal kangaroo rat with a pocket mouse, woodrat, and ground squirrel. We created fake predator attacks and measured how each rodent responded. We found that pocket mice and kangaroo rats jumped away the fastest. This might be because both are small and have strong back legs. Woodrats and ground squirrels jumped lower and slower. So, rodents jumping with 2 legs were better at reacting to attacks. This means using 2 legs may be an advantage for rodents when avoiding predators. Introduction. Predators have many different ways of capturing prey. Some predators chase their prey, while others wait and strike suddenly. It is important for prey animals to be able to avoid or escape predators. Prey can have different shapes, sizes, and speeds to help them. For example, a fly has wings that help it avoid a lizard's quick tongue. The number of legs an animal uses might also be important for avoiding predators. Do you think more legs or fewer legs help an animal escape? Most mammals are quadrupedal, which means they walk on 4 legs. Cats, bears, and mice are all quadrupedal. Using 4 legs at once may help them run fast. But some mammals are bipedal. They walk on 2 legs. Bipedal animals usually have larger back legs and smaller front legs. The kangaroo rat is bipedal and has strong back legs. It is even famous for its high jumps, like a kangaroo. Being bipedal may help the kangaroo rat jump really high. It may even help them avoid predator attacks from animals like owls and snakes. But are bipedal rodents better than quadrupedal rodents at avoiding predators? To find out, we compared the jumping ability of kangaroo rats with 3 types of quadrupedal rodent. In this image, you can see kangaroo rats are small rodents from western North America. They get their name from their ability to use their hind legs to jump to avoid predators. The photo shows a kangaroo rat standing in a clearing. Its tail is stretched out behind it, and there is foliage in the upper section of the photo. Methods. We went to deserts in southwestern North America. We captured 150 rodents. These included bipedal kangaroo rats and quadrupedal pocket mice, woodrats, and ground squirrels. We gave them tags and fur dye so we could identify them. We then released the rodents and allowed them to return to their home burrow. At their home burrow, we used a rattlesnake strike simulator to scare each rodent. This fake snake is made out of a plastic tube, a spring, and an elastic string. We cut the string so the tube moved toward the rodent. We filmed the rodent's reaction. We later watched these videos to see 1. How many of the rodents jumped, jump frequency, 2. How quickly each rodent reacted, reaction time, 3. How fast each rodent took off from the ground, takeoff time, and 4. How high each rodent jumped, jump height. Here in Figure 1, you can see a diagram of the rattlesnake strike simulator with a photo of the simulator in the desert with a kangaroo rat nearby. The strike simulator is made of a wooden board with a plastic tube taped to the top of it. Attached to the tube is a cork on a spring. The spring is rigged with a string so that the researcher can cut the string to make the cork pop away from the plastic tube. The researchers use seeds as bait to draw out the rodents from their burrows. Results. 1. We found that almost all of the kangaroo rats and pocket mice jumped when the rattlesnake strike simulator scared them. Only a few woodrats and squirrels jumped. The rest of them scrambled or ran away. 2. We found that the desert kangaroo rat and the woodrat reacted faster to the fake snake than the other species on average. 3. We saw the rodents had different takeoff times. Pocket mice had the shortest takeoff time, followed by kangaroo rats. The woodrats and ground squirrels had a slower takeoff time. And 4. There were no large differences in jump heights. A few of the kangaroo rats did jump nearly half a meter or 1.6 feet high, but most kangaroo rats did not jump higher than the quadrupedal rodent species. Here in Figure 2, you can see a comparison of the takeoff time between several kinds of rodents and the rattlesnake, a major predator in the desert. On the x-axis of the graph, you can see the different rodents and the snake. From left to right, they are the desert pocket mouse, the desert kangaroo rat, the banner-tailed kangaroo rat, Merriam's kangaroo rat, the rattlesnake, in orange, the white-throated woodrat, and the California ground squirrel, both in light purple. The 4 rodents on the left are all heteromyid rodents and shown in dark purple. On the y-axis, you can see the takeoff time in milliseconds. Looking at the graph, which rodents are faster at taking off than the rattlesnake is at striking? Which rodents are slower than the rattlesnake? Discussion. We saw that the bipedal kangaroo rats were good at reacting to the rattlesnake strike simulator. We were surprised to see that pocket mice were also good at jumping away quickly. This tells us it's possible to be a good jumper without being bipedal. Kangaroo rats and pocket mice are both part of the heteromyid rodent family. This means they are closely related. Even though pocket mice are not bipedal, they have strong hind legs like kangaroo rats. Strong hind legs can help rodents jump away from predators. Heteromyid rodents like kangaroo rats and pocket mice also have good ears. This helps them hear predators. This might explain why pocket mice and kangaroo rats jump more often and took off faster than the other rodents. In contrast, woodrats and ground squirrels end up being slower than a rattlesnake strike as they take time to run away. We know that time is important when prey responds to a predator attack. Even taking just a few milliseconds longer can be the difference between life and death. If jumping is so helpful, why don't other quadrupedal rodents like the woodrat and ground squirrel jump as much? One reason is these rodents are also bigger, so they might not be as afraid of the snakes as the pocket mice and kangaroo rats are. They are also less sensitive to rattlesnake venom. We want to do more studies to figure out the details of why kangaroo rats are bipedal and why other rodents don't jump as well. But traits like size and venom resistance must have advantages too, right? Every animal has a unique combination of features. We can understand why these combinations exist when we look at how these features help the animal survive. Conclusion. Looking at differences among animals can help us understand how and why a certain trait evolved. We saw how jumping ability may have evolved to help small rodents avoid predators. Now think about your own body. Why are humans bipedal? Why do we have an ear on each side of our head and 2 eyes facing forward? And why have humans developed the ability to read, like you're doing now? You can use the same methods as we used for rodents to think about this. What challenges have humans faced, and what sets us apart from other similar animals with different skills or habitats? Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal Ecology and Evolution, published on September 20th, 2024. Research conducted by Grace Freimiller, Rulon Clark, Craig McGowan, and others from the Department of Biology at Clovis Community College, the Department of Biology at San Diego State University, and the Keck School of Medicine at the University of Southern California, all in California. See the full list of authors and their affiliations in the accompanying PDF. Please visit our website, sciencejournalforkids.org, for more free science teaching resources. Hey everyone, we're a small nonprofit, and all of our resources are free. So if you like what you see, please subscribe and share.